Okay, so remember that we are talking about an inverse exponential when we are talking about logarithms. So when we have a graph, remember from our last, I think it was lesson 2 or lesson 3, we said that a base exponential function looks something like this with an intercept at the coordinates of 0, 1. When we take an inverse, we are swapping positions of the x and y coordinates, which means we are reflecting it along the y equals x line, means the diagonal of the graph. So we are reflecting it over, so essentially we're folding it over, and now the intersection, instead of being at 0, 1, will be at 1, 0. And instead of having a horizontal asymptote at 0, we are now going to have a vertical asymptote at 0. And we are going to have a graph that looks like this instead. So the red represents the exponential and the blue represents the logarithm. Okay, so what we're doing here is we are looking at example 1. What is the graph of y equals log of base 2 of x? In other words, I could rewrite this as 2 to the y equals x, right? That is this in exponential form. And hopefully you'll recognize from lesson, I think it was lesson 3 we did this. This is the inverse of y equals 2 to the x. We have swapped the positions of the x and y values, which means that all the numbers that we used to have are now just swapped. So x equals 2 to the y. So I can say y is -2, or how did we do it in the last one? I think we went from 3 to 3. So let's go -3, -2, -1, 0, 1, 2, 3. And then 2 to the y equals x. So then this is 1 over 8, 1 over 4, 1 over 2, 1, 2, 3, 4. Oops, nope. Try again. 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. Okay, when we did the inverse, or when we did the exponential, we had x and y, right? And we had 1 over 2, 1, 2, 4. So you can see that essentially the numbers are the same, they have just swapped positions. So when we're looking at graphing this, here we go. -3, or sorry, x values of 1/8 is at -3, 1, 2, 3, somewhere down here. And then at -1/4, it is 2. What did I do here? Oh, yes, yes, yes. Quarter is -2. And 1/2 is -1. 1 is 0. 2 is 1. 4 to 4 is 2. And 8 somewhere over here, 1, 2, 3. So we end up with a graph that looks like this. Okay. So key features and properties of logarithmic graphs. We now have a vertical asymptote at x equals 0. So we cannot cross the vertical boundary. This means that our domain is that x has to be a positive number. Our range in this case is y is all reals. because you can see that it's going to go down, down, down forever, and it's going to go to the right and up forever as well. So y now is all reals, but x is restricted to being a positive number. And I think that is all. Oh, yes, our intercept. We now have an x-intercept always at 1, 0. This is assuming that we don't have translations or transformations, right? When we start putting ERT stuff, so expansions, reflections, and translations, then that x-intercept will change. But for a base logarithmic graph, these 4 things are true. And you'll notice that they're slightly opposite of the exponentials. The exponential, we always had it, the y-intercept at 0, 1. The y value had to be positive. The x value was all reals. And we had a horizontal asymptote at 0 rather than a vertical one. Okay? So now what happens when we do the inverse of a fraction? This is the same as saying x equals y to the 1/2, which is the inverse of y equals x to the 1, or oopsie, sorry. 1/2 is the base, y is the exponent. 1/2 is the base, x is the exponent, which is again the same thing as 2 to the negative x. This is the same as saying y equals 2 to the negative, oh man, Miss Gordon's losing her mind today. X equals 2 to the negative y. So it is the inverse. So again, think of a decay graph, right? In lesson 3, we said a decay graph looks like this. Well, if we flip it over this green line, now it's going to look like this, right? So our x and y values, let's make a few samples here. And again, I'm using the same coordinates that I did in lesson 3. Okay, so -3, -2, -1, 0, 1, 2, 3. The reason here I'm starting with the y instead of starting with the x is because that y is now my exponent instead of x being my exponent. And essentially I'm working backwards. To find x, I say 2 to the power of -3. So this gives me 8, 4, 2, 1, 1 over 4, 1 over, 1 over 2, 1 over 4, and 1 over 8. Okay, so the thing that doesn't change is that I'm still going to have an x-intercept at 0, 1. So I'm going to put that there. I also know that I'm still going to have a vertical asymptote. Okay, so I'm going to put this here. Can't cross that line, right? I also know that my x values must be positive, so I'm going to stay in quadrants 1 and 4, so on the right side of my graph. And now, bless you, I am approaching the asymptote on the upper side or the left side of the graph. And then on the other side, let's see, x is 2, y is -1, bless you. X is 4, y is -2, x is 8, y is -3. There you go. Harder to graph these ones, right? Because you got fractions and they're all kind of very, very close to each other. So something like this. Okay, so this is the inverse of a decay graph, and this is an inverse of a growth graph. Okay, all of them have the same features in terms of logarithmic graphs. It still has an x-intercept at 1, 0. X must be a positive number. Y can be all reals. And we have a VA, a vertical asymptote, at x equals 0. Okay, because there's no transformation here other than a reflection, right? And also notice that this reflection is affecting the y. When I change from an inverse decay and an inverse growth, what I'm changing is putting a negative next to where the y is. So now my reflection is over the x-axis rather than the y-axis, right? Always doing the opposite of what we did with exponentials. Okay, we're going to put this into practice and do some transformations with these. In one of the comments at the top there is if you have two different functions where one is written as an exponential and one is written as a logarithm, if the bases are the same, then the functions are inverses of each other. Okay, and the proof for this is just visual again. Y equals b to the x. If I were to rewrite this as a logarithm, then this would be log base b of y equals x. So this is an inverse. Okay, so if they have the same base, if they have the same things on the inside of the log and the exponent of the exponential, right? Again, we're matching patterns here as we have been in the last lesson. Okay, let's sort it out. If the point 2, 5, highlight that, is on the graph of y equals b to the x, what point is on the graph of log b to the x? Now, by inspection, we can see that these are inverses of each other, right? I can invert this by writing it as log base b of y, that should be a b, equals x. That's exactly what I have here, or similar to it. If I swap the x and y positions, that gives me an inverse, right? So if these are inverses of each other, then I know how to map it on the graph. This is an exponential that I wrote as a logarithm. That does not change the function. But when I change the position of x and y, that is what makes it an inverse. So I change to log and then invert it by swapping the x and y. Okay, because I'm swapping x and y, I know that these two functions are inverses. Then what point is on this graph here? Well, I just changed the positions of the numbers. This point is now going to be 5, 2 on the inverse graph. Okay, so when I take an inverse of a function, I am swapping the positions of x and y. Okay, determine the inverse of f of x equals blah, blah, blah. I'm going to write this as a y equals equation. Y equals 2 to the x minus 1 plus 3. Okay, to make this an inverse, invert. Invert means swap the positions of the x and the y. So I'm going to write x here equals 2 to the y minus 1 plus 3. Okay, so step 1, I'm going to invert it. So swap the positions of the x and y. And then step number 2 is isolate y, means solve for y. Make it a y equals equation. So my y is over here, so let's move some things over. This is going to be x minus 3 equals 2 to the y minus 1. Okay. In order to get y by itself, to bring it down, step 3 is I'm going to make or rewrite this as a logarithm. Make a logarithm. So this means everything on the left side is going to have to become in brackets, right? That's going to be the inside of the log. The 2 is the base because it's the base of the exponent, and the exponent becomes its own thing. So this is going to be log, the base is 2, x minus 3 is on the inside now, and now what's left on the other side is whatever was in the exponent. And so my last step is to add 1 to both sides. So my final answer, f of x equals log base 2 of x minus 3 plus 1. And this is the inverse function. Okay, so we write it in a way that we recognize. We swap the positions of x and y, and then we get y by itself. Okay, let's take a look here. Determine the inverse of f of x equals blah, 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 blah. Okay, so let's rewrite this as a y just to make life a little bit easier for us. Log base 5, x plus 1 minus 3. Okay, so invert it first. Swap the positions of the x and the y. X equals log base 5 of y plus 1 minus 3. And essentially bed mass backwards, let's get the y by itself. That's always our goal, right? So this becomes x plus 3 equals log base 5 of y plus 1. To be able to get rid of the log, we need to rewrite this as an exponential. So again, the left side needs to go into brackets. The base of the log becomes the base of the exponent or the exponential, and the inside of the log stays as is on the other side. Yes, sir. Oh no. Okay, sorry. Let's try that again. Share. Can you see now? Good. Okay. So the stuff on the inside of the log will get left alone. The base of the log becomes the base of the exponent, and the stuff on the other side is the exponent. So this is going to be base 5 to the power of x plus 3 equals y plus 1. We have inverted it, or we have undone it, done the inverse of a log, rewritten it in exponential. And then the last step is to minus 1 from both sides. So this is x plus 3 minus 1 equals y, or we can write it as f of x. Either way is okay. This is your final answer. That's it. That's our lesson. Nice part. So in our homework today, we are going to have to go backwards in our notebook. Remember, because I put the homework 5 in the wrong spot. You are going to back up. Okay. What you want to do is go back to section, I think the title is section 4.2, numbers 6 till 13. Okay, so the title, I'm just going to write it on here. Section 4.2, numbers 6 to 13. I'm going to try to pull it up on my screen here because I do want to point something out to you. Do this one here. Oops. Remember that when we're dealing with graphs, the rules for transformation still apply. So let's recap our transformation stuff. Okay, here we go. Y equals A F bracket B, oops, X minus H plus K. Okay, we know what A, B, H, and K are. We know what they're supposed to do to the graph. When we work with logarithms, this is how it's going to look. Y equals A log base. I should have another letter for the base because it's not B. Okay, I'm just going to use B for a minute. Maybe I'll write the word base because I don't want you to get confused there. And I should have written A as a blue to match it. Okay. This is what it looks like when we take the generic transformation function and make it into a logarithmic function. All I have done is substitute a generic function with an actual base function, okay? So when you are looking at 6a, you are looking at a base 3 graph that has been moved to the right by 1, okay? So take a look in your notes. What does a base logarithm function look like? Where are the asymptotes? What's the domain and range? So take a look at page 1 of our lesson and say, okay, we know that a base graph for a logarithm function looks like this, where the intersection is at 1, 0. So if I'm moving it up or down or left or right or reflecting it, this is the starting point that you have. So what picture has this moved to the right 1, right? If I move to the right 1, I'm looking for an intersection at, what is it? 2, 0. Right there. Right? So you're just matching the picture. So just follow the key point, follow the intersection, and follow the rules of transformations that we have learned this entire course, okay? This is what it will look like specifically for the logs, and just kind of follow the patterns. In the bottom, it'll ask you to sketch something based on an original graph. So it'll give you, this is the graph of log base B of A. What happens if you put a negative on the outside? That's a vertical reflection, right? What happens if you put a negative on the inside? That's a backwards reflection. What happens if you invert the base, right? That's going to be a compression of some kind. So go through and take a look. Follow the patterns of transformations that you know. That's the first page. And then the second page is solving equations. So this is the same as what we did on page 2 of today's lesson. Okay, any questions, comments, or concerns? Okay, off you go. You're ready to go.